35 says 3s squared plus 2 equals negative 62. Okay, so the first thing we want to look at in this problem is possibly what method we're going to want to use to solve it. Remember, we had those 4 methods from yesterday. What do you think? Square roots. Do you know why? There's no s term. It's called the linear term. Okay? The s squared term is called the quadratic term. The s term is called the linear term. Okay? There is no linear term in this quadratic equation. There's only an s squared. So therefore, if we just isolate s squared, we can solve it by taking square roots. So let's subtract 2 from both sides. So we have 3s squared equals negative 64. Now what? We've got to divide by 3. So s squared equals negative 64 thirds. Okay, well now we have to finally take the square root of both sides. When we do that, how many solutions do we get?
2.
2 of them. What are they?
Plus positive and negative.
And make sure we say plus and minus. Positive and negative. It's not positive or negative. They are both solutions, not one or the other. Okay? So plus and minus. Now, when we take a square root, okay, first thing I see here is I'm taking the square root of a negative number. What happens there? Pull an I out. Pull an I out. So it's I. Next, we're now taking the square root of 64 thirds. When you take the square root of a fraction, we talked about this. This is a rule from Algebra 1.
Yeah. Square root.
It's top and the bottom, right? You take the square root of the top and the bottom. So that's the square root of 64 over the square root of 3. Okay, well, obviously the square root of 64 is going to be 8. I get that. But do we want square roots in the denominator? No. So what do we do for that? Do you remember? Multiply by the square root of 3 on the top and the bottom. Yes, ma'am. Very good. So we have the square root of 3, the square root of 3. We're multiplying by 1, right? But we're making it look different, right? So I'm going to take I, woo, that's not what I want to do. There it is. I times 8 times the square root of 3. I times 8 times the square root of 3 gives me positive and negative 8i square root of 3 over, what's the square root of 3 times the square root of 3? 3, because it ends up being the square root of 9, right? Square root of 3 times square root of 3 is square root of 9. The square root of 9 is 3. And there's our answer. Questions? Yes, sir.
47.
47. What's 47 say?
In parentheses, x plus 3i. Do 47. Another one, x plus 3i. Equals 32.
34?
Yeah.
Yes, 47 was part of your assignment.
Oh, it's just not good.
Yeah, it is.
Oh, I didn't.
Okay, so in this problem is not written in standard form at all. Okay, not even close. Okay, we have a quadratic that's factored over here, and then over on this side we have a whole number. We don't want that. Yes, ma'am?
It's x plus 3i, x minus 3i.
Oh, is it? Okay, thank you. That would cause a problem as we started working this. Okay. All right. So, what we need to do then is we need to go through and multiply those two complex numbers together first. Okay? So we're multiplying those two together first. That means we have to FOIL. So x times x, x squared, x times negative 3i, 3i times x, and 3i times negative 3i. All right. Now let's start reducing. So what happens?
Well,
the negative 3ix and the positive 3ix go away. And then I squared is,
Positive. Makes it a positive.
right, we have, that's a negative 1, so therefore negative 9 times negative 1 is positive 9. Thank you. And so we now have x squared plus 9 equals 34. Okay? Something else, just as a side note. Just as a side note, this does not pertain to the problem at this point in the game, okay? But take a look at what we have. This right here, x squared plus 9. Remember way back when we talked about a way of factoring binomials if they were a difference of perfect squares? Remember hearing that phrase at least? Difference of perfect squares? Okay. Well, x squared is a perfect square. 9 is a perfect square. But we have a sum. It's addition. Okay. I told you there was no rule for the sum of perfect squares. Which I kind of lied to you about that because the reason is there's no rule if you're dealing with real numbers. Right? Because look at how that guy factored. X squared plus 9 factors into a very similar form, x plus 3, x minus 3, but now we have to use imaginary numbers, right? It's x plus 3i and x minus 3i, okay? So that's why when you're solving quadratic equations, solving by factoring only works if you have real number solutions, right? Because factoring involving i's, it gets very difficult, it gets very complex, and we just kind of stay away from it because we have other methods that get us to the answer easier, right? Okay. So, we're almost done. Now that we have it written in something that's close to standard form, now we can look at the equation and decide what method we want to use to solve this. What do you think?
Subtract 9.
Okay, so because you're trying to set up what?
Square root.
We're trying to set up square roots, right? We want to solve this by square roots. So let's subtract 9 from both sides. So x squared equals 25, which we now take the square root of both sides, positive and negative 5. There we go. Got it?
Yep.
Questions?
40.
Any questions on 47 before we move on to another one? No? Doing all right? Okay. So then, yep.
What if, like, say that x has a number in it, and then, like, say you got 3i to, like, 3ix.
Right.
Instead of being 1, it actually had another.
So, okay. So you're saying, what if this was like a 2x plus 3i, and then we had to distribute? Well, the issue there is that this problem would then become much more complex to solve, and yeah, we're not going to do that. Yeah, we're not going to deal with that because that would then mean that these middle terms wouldn't cancel away, right? Yeah, that's a whole different ball of wax that we're not going to deal with at this point. Okay? Any other questions? No.
40. Negative 3x squared plus x minus 3 is equal to 0.
Is it in standard form?
Yeah.
What method do you want to use to solve it?
Quadratic formula.
It
What?
says in the directions.
Yeah, it
It says quadratic formula, then we better do it by the quadratic formula. Okay? Just for giggles, what if we try to do this by factoring?
It won't work.
Yeah, sadly it won't work because we take negative 3 times negative 3, that gives us 9, and 1 is b, and I can't think of any numbers that when I multiply give me 9, but when I add them give me 1. Doesn't work. Okay, so we can't do it by factoring. I would not do this by completing the square because I would have to get rid of the negative 3, right? And if I divide everything by negative 3, it ends up with all sorts of nasty fractions throughout my problem. It would work, but it would be much more difficult. So let's not do it that way. We can't solve it by taking square roots because we have that linear term in here, right? The x term is in there, so we can't do it by solving by taking square roots. So that doesn't work. So the directions say to solve by the quadratic formula because that actually ends up being the easiest way of solving this guy. Okay? So what is our A value? -3. What's our B value? 1. What's our C value? -3. So x equals -b plus and minus the square root of b squared minus 4ac all over 2a. All right, so what are we plugging in for A? For A?
Oh, sorry. No. -3.
B? C. So x equals -1 plus and minus the square root of 1. And now what's -4 times -3 times -3? Positive or negative 36? -36 over -6. Okay, so 1 minus 36 gives us what? -35. So we have -1 plus and minus the square root of -35 over -6. All right, we got a square root of a negative number. What do? Pull an eye out. That means we've got to rewrite this as a complex number, right? Real number plus or minus the imaginary number. So we take -1 over -6 plus and minus I square root of 35 over -6. So what happens in the first fraction? The negatives cancel. It leaves us with positive 1/6. Plus and minus. What happens in the second fraction? So the negative moves up into the plus and minus, right? So therefore, we really don't need that negative there at all. So I'm just going to say plus and minus I square root of 35 over 6.
Now simplify 35.
Square root of 35 factors into the square root of 5 times the square root of 7. Neither of those are perfect squares. So yep, we can't do anything with it. All right. Questions on 40? No questions on 40. Anything else you want to see? All right, first and last name at the top, pass them back. So, taking a look at our worksheet, we want to see number 1 first. So the first thing I see in number 1 that we're going to want to do is rewrite this in standard form, which means I need to add 29n to both sides. And I need to subtract 42 from both sides. All right, so we have 5n squared plus 29n minus 42 equals 0. Can we factor out a GCF? No. So at this stage, we get to choose how we're going to do it.
Quadratic formula?
Quadratic formula is definitely an option. You guys okay with that? Yes. All right. So, the quadratic formula. X equals -b plus and minus the square root of b squared minus 4ac all over 2a. All right, Dylan, what are we plugging in for A?
A, 5.
B.
29.
C.
Negative 42.
Yes? So you brought that to the other side? Yeah, that would be fine. You're going to have some different numbers here, but your final answer should end up being the same. Yep. Final answer should end up being the same. All right, so we now have negative 29 plus and minus the square root of, what is 29 squared? 841? And now we've got to take negative 4 times 5 times negative 42.
840.
Positive 840? Over 10. Okay, Allie, you have your calculator out. What's 841 plus 840?
1681.
Get it back out again, please.
1681.
Allie's got it. What is it? What is it? Yeah, you have the calculator. I asked you. So we have negative 29 plus and minus the square root of 1681. All over 10. Cool. All right. How lucky are we? Is 1681 a perfect square?
Yeah.
Nice. We're super lucky. What's the square root of 1681?
41.
41. So x equals negative 29 plus and minus 41 over 10. You cannot leave your answer like this. You have not told me what the answers are yet. You have to take negative 29 plus 41. What's that give us?
12.
I've heard two different answers so far. 12. What is negative 29 minus 41? Negative 70. Well, now we need to reduce our answers. So what does 12 tenths reduce down to? Say it again.
122.
We don't want decimals. Reduced fractions.
6/5.
6 over 5. It cancels 2 at top and bottom. So we have 6/5 and negative 70 divided by 10? Negative 7. There's our two answers. Well, it would have been shorter had we done it by factoring. But you guys chose quadratic formula, so that's how we did it. If you choose a different method, then speak up. All right, drive your own bus. Okay, questions on number 1? No. Okay, anything else you guys want to see? 7? All right, number 7. So for number 7, first thing we need to do is rewrite this in standard form. So what I'm going to do is I'm going to subtract 20x from both sides. I'm going to subtract 98 from both sides. Now I'll rewrite. So 10x squared minus 20x minus 98 equals 0. Before we go any farther, is there any GCFs we can factor out of that? We can factor out a 2. So why don't we just divide everything by 2? So we have 5x squared minus 10x minus 49 equals 0. Okay. Next, we've got to decide how we're going to go about doing this. Think we should do factoring? Okay, let's give it a shot, if nothing else, right? Let's give it a shot. So we draw our x, and we take 5 times negative negative 49. Gives us negative what? 245. Okay, and then negative 10 goes down below. So we need two numbers that when we multiply give us negative 245, but when we add give us negative 10. One of them is going to have to be negative. If you're uncertain what you're doing, you can factor 245. We know that at least what goes into it. How about 5? Because we know that 5 times 49 gives us 245. But sadly, 5 and 49, even if one of them is positive, doesn't add to give us negative 10. Right? We know that 49 is 7 times 7. So we can have 35 times 7. Even if one of them is negative, that still doesn't give us negative 10. Is there anything else that goes into 245? No, because these are prime numbers. 5 times 7 times 7 are all prime numbers. So that's it. We can't actually factor this one. Doesn't factor nice. So it was a nice try, but we can't solve it by factoring. You want to do the quadratic?
Yeah.
Somebody else want to try completing the square? Okay, let's try completing the square. So for completing the square, we want to go through and add 49 back to the other side. So we now have 5x squared minus 10x equals 49. What's the next thing we want to do? Nope. Nope, we don't want to cut the b term in half yet. We got to get rid of the 5. So we got to divide everything by 5. Okay, so we have x squared minus 2x equals 49 fifths. Cool. So now we want to find out what we're adding to both sides. So it's x minus 1. If I square negative 1, I get 1. Now I don't want to write 1 over here, over on the right side. I'm going to write what instead? It's a special kind of 1. 5 fifths. Yes, ma'am. Because I need to add those up, right? I need to have a common denominator. So 49 plus 5, 54 fifths is what we have. We want to take the square root of both sides. All the reduction we're doing now, all the nasty fractions we're dealing with now, we'd have had to deal with as well in the quadratic formula. You know, it's not so bad. It's not so bad. So if we took the square root of both sides, we have x minus 1 equals positive and negative. Now remember, the square root of 54 over 5, we've got to break that up, right? So that's going to be the square root of 54 over the square root of 5. Do we like a square root in the denominator? Nope. What do we do to that then? By what? By the square root of 5 over the square root of 5. We've got to get rid of the square root in the denominator. So we have x minus 1 equals positive and negative. Now, here's the thing. What is the square root of 54 times 5? Someone with a calculator, push some buttons for me. You should be taking 54 times 5. 270?
Yeah.
270 over 5. So because the square root of 5 times the square root of 5 is the square root of 25, which is 5. So lastly, we're going to add 1 to both sides. So x equals 1 plus and minus the square root of 270 over 5. Before we call this done, we got to check the square root of 270. Is there a perfect square that we can factor out of 270? 9 goes into there. 9 times what gives us 270? Well, you got a calculator right in front of you. Check it. Don't say 30, I think.
No.
So 9 and 30 give us 270? Yes, you're 100% right. So, what does the square root of 270 reduce down to? 1 plus and minus 3 square root of 30 over 5. You could have done the quadratic formula, but I mean, I think they're equally difficult or equally easy. Give a pass. Thank you. Okay. Any questions? Yeah, this was a longer problem. It was a longer problem. No questions? Doing all right? Feeling good? What else can I help you with? Anything else you want to see? 17. All right, cool. Now, looking at 17, what method do you think we're going to use to solve this guy? Square roots. Because there's no linear term. Remember, the linear term is where it's just p, right? We have a quadratic term, which is p squared, but we don't have a linear term. So, we can solve by taking square roots. So what we need to do then first is what? Add 144 to both sides. So 4p squared equals 144. Now what? No. Divide by 4. So p squared equals 36. Now what? Take the square root of both sides. So we get p equals positive and negative 6. Excellent. You say we do 12? Okay. All right, looking at 12. What are you going to do first? Subtract 23 from both sides. Yep. Now, if you look at this equation, it has both a quadratic term and a linear term. It has both a squared and a. So we can't solve by square roots. Is there a GCF, or greatest common factor, we can take out? No. Bummer. Okay. Then we're left with two options. We're left with completing the square or the quadratic formula. You want to try the quadratic formula? Good choice. All right. So then we go ahead and write down a equals negative b plus and minus the square root of b squared minus 4ac all over 2a. What are we plugging in for a?
8.
B.
Negative 15.
And C. All right, we're going to need some calculator work on this one. So a equals negative 15 plus and minus the square root. Now 15 squared is 225. But what's negative 4 times 8 times negative 23? positive 736. Is that what I'm hearing? Okay. Over 16. All right, so A equals negative 15 plus and minus the square root of, what is that? 961? Sorry, I didn't hear you. 961. Did you say that was a perfect square?
Yes.
Sweet. Must be all the clean living. All right. So it's, what is the square root of 961? 31. Perfect. Again, you can't leave your answer like this. We actually have to break that up. So negative 15 plus 31.
16.
So we have 16 divided by 16, and the other answer is negative 15 minus 31.
Negative 46.
Negative 46 over 16. Well, 16 over 16 is 1. And negative 46 over 16, what goes into both of those numbers? Two? At least 2. 2 goes into 46 how many times? 23 times. 2 goes into 16? 8 times. Can you reduce 23 and 8? Nope, so there's our answer. Negative 23 eighths. And there we go. Any questions on number 12? No? Okay, why don't you guys get working on this? If you have questions, raise your hand. I'll be around as quick as I can to answer any individual questions you have.